Hello, I'm Greg, and this is the fourth video in my series on how to make Defender in Unity. So, if you've been wanting to learn how to write a game from Unity and Scratch, then just grab your favorite beverage, pull up a chair, and follow along as I teach you how to write Defender in Unity. So in the previous video, I wrote some code that was really a bad example of how to handle something, and I want to correct it in this video. So if you remember, in our background mountains, we added this background scroller, and I'm going to drag a mob onto here so I can demonstrate the problem that I was trying to fix. And so there we've got our human right here, and if we were to hit play and we scroll, well, actually, yeah, you can see that it's not scrolling at the same speed. And the problem we were trying to fix, and I think the reason it's not working, is because I was in play mode when I changed these values in the last video and I never saved them. But if we were to scroll now, you can see that the mountains are scrolling at the same speed as the mob. And the way we handled that is I basically just played around with this number until I got a number that worked. And that's not really a good way to fix this. And I'm going to show you the right way to fix it. And the way we're going to fix it is I'm going to hide these mountains here. I'm going to, and the reason this is happening, by the way, is I just dragged a sprite onto here, and then I added this script to a sprite. And there's no real concept of how big this item is in terms of a world unit. And if we go into the script and look at what we're doing, we're setting the texture offset. And if I was to set this texture offset 1 in the next direction, I'm telling it to move one world unit, one whole world unit. And that, how much that moves depends on how big the world unit is that this object is sitting on. So we're going to go see how we can fix that by using a quad. Basically, I want to have an object in the scene that I can use to represent a world unit. So right now, this is one world unit. And I'm going to add a material to it. Right now, you see us using the standard material. So let's go into our Defender folder. I'm going to create a new folder, and I'm going to call this Materials. I'll go in there and I'll create a material. And then up here, we're going to drag in from our art folder those background mountains. And so you can see they're right here. And if I was to take that material and drag it onto our, well, actually I should do it in the scene view here. If I was to drag that onto our quad, you can see it's got the background mountains. And I don't really like the way that looks right now, but let's move it down a little bit. Just get it down into the scene. And we can stretch this and say we want our map to be 150 units wide. Now, this is not what we want at all, because it's basically stretching that entire image over that whole 150 units. So what we can do is go back into our material. I want to rename this material too, by the way. I want to call this Background Mountains. And we can take that material and we can tile it. Now, if we were just to set it to 150, basically we get that same material tiled 150 times. And I don't like the way that looks. I do want to make it a little taller. So let me go up here and scale this a little bit taller. And I'm going to move this up a little bit. But I still don't really like the way that looks. So what I can do is I can go back into this material and I can reduce how much I tile it. I think something like that looks a lot better. Now, if we go back and we try and play and fly, you're going to see that the scroll speed, assuming that we add our scrolling script to it. So let's go into our scripts folder and drag that background scroller, drag our mesh renderer down here. We don't need a mesh collider, so I'll remove that. If we go and hit play, And I'll make that. You can see that the mountain is scrolling faster than the mob again. And I could sit there and play with those numbers until I get a value that works. But what we need to do is we need this to actually be a ratio. And so we know that we're tiling our material with a width of 25. We basically have this tile 25 times, but then we have this set to be a width of 150. So what we could actually do is we could say, this is really cool. You can actually type an equation in here and it'll calculate for you. So let's say 25 divided by 150, and that gives us that ratio right there. And let's hit play. And now you can see they are matching. But even that's not the best way to fix it, because then what if I was to go in and change this scale here? Or what if I was to go and change this scale here? I would have to remember that I'd have to come in here and change the scroll speed. So there's a much better way to do this. I'm going to rename this to be background mountains just to be consistent. If I can type. All right, I'm going to go into my background scroller script, and I'm going to remove this scroll speed. I'm going to remove the serialized field attribute. So this is now a private variable, just like all these other variables. And I'm going to just default this to 1. And then down here, we're going to calculate that scroll speed in awake. We're going to say that scroll speed equals, and you see how we've got this cached property ID here, and we're using it to get the texture offset. Well, we can actually use that here. We can say renderer.material get texture scale, and we'll again use that main text, and we want the X scale. And then we want to divide that, if you remember, by our transforms local scale.x. So now we are calculating our scroll speed. I'm going to rename this too. I don't think scroll speed is what I want. I think what I want this to be is scroll speed factor. So that is a factor which we're multiplying against the player ship speed, the player ship direction, and time, that delta time. So now it's calculated based on how much we're tiling that texture. So basically its scale is that tiling value that I set. And we're dividing it by how much we scaled the actual parent object that that's sitting on. That's our background mountains quad. So let's go back into Unity. And you'll notice that this serialized field will disappear. So that's gone, but we are calculating it inside that function. So let's hit play and see if it still works. And there it goes. Now I think the ship is moving a little bit too slow. So let's change the ship speed. We'll go into our prefabs, player ship, and let's bump this up to something like 15 and hit play. Yeah, I think that's better. It might be a little bit fast, but that's something we can tweak to taste later on. So that's a much more elegant way to solve that problem, and it's flexible. So if I was to come in and change the size of our map, change that scaling, or if I was to change how much I'm scaling this material, it would recalculate that scroll speed factor, and it would continue to move at the right speed. And I'm just going to delete this guy now that we're no longer using him. Now, in the previous video, I spent a lot of time talking about unit tests and test-driven development and setting up a CI pipeline. And I wasn't sure if that's what my audience was really interested in, so I did submit a poll on my channel. And right now, I'm actually surprised by this. Continue writing unit tests and doing TDD is slightly favored above just focusing on finishing the game. I'm honestly, quite frankly, surprised by that. I'm not going to make unit tests and TDD the primary focus of this game, of this video, but I am going to do a little bit with it since it seems like people are interested in that. One thing we want to do is we want to make sure that the tests that we already had are still running now that we just made these changes. So I'm just going to say run all. And there it goes. You can see they still pass. And I'm sure you noticed the weird behavior when we ran this test where there were 2 ships on the screen. I'll go ahead and just run that test again so we can see it happen. And there's 2 ships there. The test still passed, but we don't want that to happen. So let's go open up the source code for that and see why that might be happening. So we're loading the mob test scene. We're getting the game manager, and then we're calling start game on the game manager. Now if we go up and look at the game manager, you can see that when it is enabled, it already calls start game. And if we go back and we look at our scene, we'll go and look at our test scene, mob tests. Under managers, there's already a game manager and it's enabled. So just by virtue of loading the scene, this game manager will get loaded and its on enable will get called, and its on enable will call start game, in which case it will spawn a player ship. So by our test calling start game again, we're basically telling it to spawn a second player ship. So let's jump back out into Unity. And we'll rerun that test now that I've deleted that start game call. And that looked a lot better. So I'm going to go back into our player movement test. And I want to add a new test. I want to test that the background scrolls. We've already seen it working. So we're not exactly doing test-driven development here. I just want a test to cover that the background scrolls. We'll say background should scroll, if I can remember to put my underline, scroll when ship thrusts. Okay, so in our setup, we're getting our user input and we're getting a player ship. In this test, we also want to get the background. So basically, we want to get the background scroller component. So I'm going to say background scroller, BG scroller equals find object, well, I want to do game object, find object of type background scroller. And I want to assert, we need to get the texture off of this guy. We need to get its renderer, and we need to get its texture, and we need to check the texture's offset. So let's say renderer equals background scroller BG scroller dot get component renderer, and we need to call that renderer. And we're going to need to get the material, the texture offset of the material off it. I'm going to grab the material. So we'll say material equals renderer dot get, let's see, well, material dot get texture offset, and it was main text. And of course, rider is actually not text. I did that before. Rider is going to warn me that we're being very inefficient and it wants me to do a cache property index, but this is a unit test. I don't care. And I got to give this a name, material. So this should get our main material. Well, this will get our offset. Let me just grab our material. Well, I don't even need to do that. I'm just going to grab our offset. That will be a vector. Is that a vector 2? Yes, a vector 2. And I'm going to call this offset. All right, so we're getting our background scroller, we're getting the renderer, and then we're getting the offset of the renderer, and we're going to assert r equal offset, and actually we want to put the value first, vector 2.0 offset, and I will say material offset should initially be 0. All right, so this is our arrange. Now we want to act, and then we want to assert. So we are going to set our user input or player input. Yeah, well, no, what is it? User input. We want to say user input dot instance dot is thrusting dot returns true. And then we want to yield return new wait for seconds. I always do that. Wait for seconds. A quarter of a second should do it. Now we want to assert. Our assertion, so we're facing to the right. The offset, I believe, should move positive in this case. So I think we want to check to see if its offset is greater than, its offset on the x-axis is greater than 0. So we will say assert. Well, let's just grab the offset from it. Offset, and I'm just going to copy this line. And we're going to assert is true. Offset.x is greater than 0. And we'll say offset should be greater than 0 after ship thrust. All right, let's go jump out into our Unity editor. And we will run selected. And it failed, and we got a failure because object reference not set. And the reason this is happening is because we're loading the player movement test scene, and the player movement test scene does not have the background. So if we go and look at our scenes, and we look at our test scenes, we look at our player ship test, there's no background. But if you go and look at our mob test, we've got the background there. So I'm going to create a prefab here. I'm going to call this create folder. Well, I'm just going to put it in that folder. I'm going to drag this whole thing here. And that's now a prefab. And so now if I go into our test scenes and I go into our player ship tests, I guess I can save that. I'm going to drag that prefab into our scene so we have a background. Let's run this selected scene again. Go to selected test. And it still failed with a null reference exception. So the background scroller script is failing because there's no game manager and is trying to get the player ship from the game manager. So we probably should create a prefab for the game manager as well. If we haven't already. We have not. So let's go back into our mob test scene and under managers, drag our game manager prefab into there. Go back into our player ship tests and managers. We'll drag a game manager into the scene. I'm going to move it up there. And let's see if that works. Of course, it's going to spawn a player ship. Let me just disable that and see what happens when that test runs. Run selected. And this time it just failed because it did not appear to move. And I'm wondering if it moved but in the wrong direction, possibly. We definitely saw there was a ship there. So let me run all the other tests and make sure I haven't broken any tests. So all the other tests passed. It was just this one that failed. So what we can do is we can actually debug that test. If we go into our source code or open the error line there, and I can put a breakpoint right here, and then I can right click here and I can say debug unit test. All right, so the offset, it's still 0. So I know in our test setup we are mocking the user input. And then in our test, we are telling that mocked user input to return true for is thrusting. So it should be handling that thrust and scrolling, setting the offset of this renderer's material by the ship's speed. So I'll go ahead and let that fail. And you can see the unit test failed. And what we can do then is go into our background scroller. And this should work here. The only question is whether this is returning an actual player ship. I think it's possible we're returning here without ever getting the player ship. Anyway, let's just debug this test again. And we have hit a breakpoint. And we have a player ship, but it does not think that we are thrusting. And the reason is we're grabbing user input by doing find object of type. We need to change this the same way we did in the other class. We want to make sure that we're using the instance from the singleton. So this is why we write unit tests. Not only do we find out if we're breaking anything, but we also find out if we have any code that's just not correct. So I'm going to get out of our debugger here. And we're going to go back into that background scroller. And here we're going to replace this with user input.instance. And I'll bet you $1 to donuts it's going to pass this time. Well, you look at that. It passed. And we'll run them all just to make sure they all still pass. Yep. Okay, there was one issue that I wanted to address. I'm going to go back into our main scene. And just so it won't be so annoying, I'm going to turn our sound off in the game view here so we can toggle that off. And I'm going to hit play. And I noticed an issue with our thrust. Sometimes when I drop below the mountains, sometimes we don't see the thrust. Seems to be mostly when we're going right, but I have seen it going left as well. So I think the issue there, if we go into our prefab for our player ship, and under particles, we look in the inspector and go down to the renderer, I think we need to set its order and layer to be something higher than the background layer. But I don't really like it being in front of the ship. That looks better. All right, so another issue fixed. I want to address another issue I discovered when I tried to build the standalone build that was produced by our GitLab CI pipeline. I thought it was an issue with GitLab at first, so I actually built another standalone version of the game. So if you go down to build settings here under file, and you click build, so I'm under Windows, Mac, Linux, I'm building a standalone Windows build, and I'm going to build it out to this Defender folder. And that'll take a while, so I will pause the video while that happens. Okay, so it finished building and it opened up the folder that it built to. And I'm going to demonstrate the issue here. There's a problem with the way that I implemented our bootstrapper to load our sound manager and our user input manager. The issue manifests itself when it tries to load the title screen. It will play the start sound and it will display the main text on the screen, but it never fades in or zooms in the logo, and it never enables a prompt to press start to play. So let's double click this. And there you see, we got this text, but it never faded in the logo, and we don't get the prompt. And I can hit space all day long and it's never going to go to the main scene. So I'm going to hit Alt F4 to close that. And there's a couple of things I need to do to fix it. The first thing I want to do is go into our title scene because the way I'm loading my title screen is wrong. If you remember, we should be accessing it through the singleton instance. And you can see in here I'm doing find object of type. So we want to replace that with user input.instance. I want to run the game in the editor so you can see another issue. So I'm just going to let it run and then stop. And you see this warning here, don't destroy on load, only works for root game objects or components on root game objects. So this was a really silly oversight on my part. In my haste to get the video out for the previous episode, I made a very foolish omission or oversight. If you go and look at the script for the input here, you can see I'm calling don't destroy on load in the awake method as part of our singleton pattern. And this is the way you would normally implement a singleton, but the problem is this script is a child of the persistent components object of the prefab that we created in our resources folder. So if we go and look here and open up this prefab, you can see the sound manager and the user input are both children of this prefab. The other thing is I don't have a script on this prefab to implement the singleton pattern here. So let's go ahead and do that. Under managers, I'll go ahead and create a new script. And I will just call it persistent components. And I'm going to drag that guy up there as soon as Unity gets finished building. And let's open that up in the editor. And we're going to create a static persistent components instance field. And in the await method, we're going to say that if instance is not equal to null and instance is not equal to this, then we want to destroy the game object and return. Otherwise, assign this to instance and call don't destroy on load on the game object. So we're implementing the singleton pattern on the parent object. The other thing is in our bootstrapper, I'm using this subsystem registration for the runtime initialized load type. I'm not sure exactly why, but there seems to be a problem with the way that Unity handles domain reloading, where if I use this type, it will clear the static references. And so if I've already got a static reference and then this happens, somehow it gets lost. So I'm going to change this to before scene load. And now let's go back into Unity. And first of all, make sure that we can still run in the editor. I want to switch to our title scene. So scenes, title scene. And I disabled the audio in the game view, so that's why we're not having any audio. And there, I can start the game, I can thrust around, all that works great. And we should no longer see that warning about don't destroy on load, can only be used on root components. Okay, so let's try it with a standalone build. And there's our title screen. There's our prompt. And it's all working honky-dory. So the next thing I want to do is I want to add an enemy. I think the lander would be a good one to add first. So I'm going to go back to our main scene. And I'm going to create an empty game object. Let me expand this out a little bit. And I'm going to call that lander. And then I want to go into our art folder here. And let me blow this up a little bit. And there's actually going to be a couple of sprites that we're going to use for the lander. If I was to open this up in the image viewer, you can see that there's a couple of different ones. And it looks like he looks from left to right. So he just kind of like, I think he kind of oscillates between these images, and then depending on whether he's moving right or left, he moves between them. But for now, I think I'm just going to drag this guy here onto him. So drag that onto there, and I'm going to add a box collider. And I'm going to edit that. Let me double click on that in the scene and edit that collider and just kind of bring that in a little bit. We don't need that collider to be nearly that big. And I think that looks pretty good. And later we'll add a script to this guy which will animate the different images that he'll show. You can see him in the scene over here. I want to add that mob scroller script to him. So if we go down to our scripts folder, mobs, and we will drag the mob scroller onto him. So now if we were to fly through the scene, we should see that we can fly past that guy. Right? And so that's working. And he will have another script that will allow him to also move independently. We're going to implement a state machine where he's going to have like a patrol state where he'll fly around and occasionally throw off projectiles. And then if he comes over a human, he can go down and grab it and try and fly off the board with it. And I'm going to want to be able to blow him up. So let's go and create a new folder under our prefabs. And I'm going to call it effects. And right here in our scene, I'm going to right click, create empty, and I'm going to call this explosion. And we're going to want to add a particle system to it. And let's go ahead and configure this. We want it to be very quick. It's just an explosion. So we'll set the duration to be 0.1. We don't want it to loop. For our start lifetime, I'll set it to 2. Start speed 5 should be fine. We want the particles to start pretty small. I'm going to try and match what I've seen in the actual Defender game in terms of how the explosions look. For the start color, we're going to want to do random between 2 colors. I want to pick a yellow and a red. And we want the simulation space to be world. Simulation speed, fine. Max particles, this probably is overkill, but we'll say 5,000. For the stop action, we want to destroy the particle system. Now let's go take a look at emission. Rate over time, let's be crazy, something like 2,000 particles. That's already starting to look kind of interesting. Rate over distance, I think we're going to leave that all as it is. For the shape, we don't want a cone. We want a hemisphere. Actually, we want a sphere. Radius should be... Do I want it to be that big? Let's make that about half of that. Actually, even that looks kind of big. Doesn't seem to be having much effect. What does radius thickness do? That still doesn't seem to have much effect. We'll leave that as it is. I don't think we're going to use a texture, but I am going to create or use a material for it. So we got our shape. So for velocity over time, for the speed modifier, I want to do a curve. So let's just go down like that. So it starts off fast and then slows down. Okay, and then for color over lifetime, let's turn that on. For our initial color, let's start with something kind of bright, like a bright yellow. And then for our ending color, we'll go to something kind of dark, like a dark orange. And actually, let's add another point here. We'll make that kind of orangey. And then we want to fade out the alpha here. So it just kind of fades out. All right. And then for size over lifetime, Yeah, that looks good. I still think it's a little bit too big though. Let's go and look at our renderer. We're going to want to give it a material. We also want it to display in front of everything. So we'll give it a 3 for the sorting layer. And for our material, let's use the default particle. There we go. Now we're getting somewhere. Cool. And I'm going to drag that into our effects folder as a prefab. And then on our lander, we're going to create a new script. And I'm going to create it right up here in the root of this scripts folder. I'm going to call it Destroy Me. And I'm going to drag that script onto our lander. And let's open that up in Writer. I will zoom in here. So let's add a serialized field, game object, and this will be our explosion prefab. And we have a public void destroy me function, which will, oh, it doesn't like that having the same name. Let me rename this. I'm going to call this destructible. And it renamed the file too, which is what we want. So now we will instantiate the explosion prefab at our transforms position, and for rotation we'll just use quaternion identity. And we will destroy our game object. And now I'm going to show you a little trick of how we can test this right in the editor. So I'm going to add an attribute here called context menu, and I'm going to call it destroy me. And if we go back out into the Unity editor, we have our lander here, and there you can see them right there. We're going to drag in our explosion prefab object. And if we right click this, you'll see this little destroy me context menu. So if I hit play, it's going to go maximize. So let me stop that. And we want to play focus. Oh, let me delete this explosion from the scene. Hit play, and then I will select our lander in the inspector, and I will right click on it and say destroy me. And there he goes. He's destroyed and he goes away. We also want to add a sound effect for that. So I will open up our explosion prefab, and I will add a component, audio source. Actually, I'm going to do this from the code. Oh, we don't have a script for that. Never mind. I was thinking that we could add a required component of type audio source, but since this doesn't have a script, I can't do that. So I will add an audio source, and we'll expand that out. Now we need to give it a sound, and I actually am going to download another sound effects pack for that. So like before, I went out to itch.io and I said browse assets. I selected free, I selected sound effects, and I selected retro for my filters. And I scrolled down and saw this sound effects mini pack 1.5. And it says it's got explosions, it's got laser weapons. It just looked interesting. So if I go and click download now and say just take me to the downloads, I've got this download button here, and it is downloading it. You can see I actually downloaded it already, but if I go into that file, if I go into my downloads and I open that file, you can see it's a zip file. So it's got all of these sounds in here. It's got different formats. So it's got the MP3s, it's got WAV, OGG, FLAC. I'm going to use MP3s for our game. And I'm going to bring all of these explosions into our game. So what I'm going to do is go back into Unity. And I'm going to go to our sounds folder here. And I'm going to right click, show and explorer. And then in there, I'm going to right click, new folder. And what was it called? Sound Effects Mini Pack 1.5. So I will move that out of the way and then grab that other window. And I'm going to drag all these explosions into there. And there were some other interesting sounds. There's a laser weapon sound. There's some hit sounds. I'm just going to drag all of them in. We can listen to them later. And go ahead and close these. Go back out into Unity and let Unity import those files. And we'll open that up. All right, so I like this one. No, this one. Yes, I like that one. Okay. Okay, I'm going to leave all that as it is. If we go back up to our explosion prefab, we got our audio clip here. I'm going to drag explosion 1 into there. And now if we go back out into our scene and hit play, and we'll pick our lander again. And I will right click and say destroy me. We hear nothing. Let's go back and look at that explosion again. It is set to play on awake. Oh, remember I disabled our sounds in the game view. Let's just make that a little bit bigger so we can see what's going on. Go back to our hierarchy, pick our lander, right click, destroy me. And there we go. So let's get our little lander here animated. I'm going to go down into our scripts folder. And I guess I'll put this under mobs. I'm going to right click, create a C# script, and I'm going to call this sprite animator. And I'm going to select our lander and drag that on there. Or wait until Unity recompiles scripts and then drag it on there. Unity is so fast. Okay, so now I'm going to double click this to open it up in the editor. And we want to create a serialized field, which will be an array of sprites. And I will call it sprites. And I'm going to want to have a serialized field that will be a floating point value, and I'm going to call that frame delay. And we're going to want to have a float that will be our next frame time. And I'm going to initialize this to maybe 1/4 of a second. So in onEnable, I am going to set next frame time to equal time.time plus the frame delay. Oh, and we're going to need a renderer. So let's add a serialized field for that. Renderer. Actually, I'm going to make that a sprite renderer. And we'll just assign that in the inspector. I could do like I've done before and create a private field and then grab this in awake. But since all this is assignable in the inspector, we'll just go ahead and inject it that way. Now in late update, I'm going to animate our sprite. So basically I'm going to say that if time.time is greater than or equal to our next frame time, then we're going to set we need an index into our sprite array, don't we? So let's create a int, and we'll call this frame. I'll go ahead and set that to 0 here. So we'll say that I like to be explicit in my naming, so I'll say advance to next frame. And all we're going to do in here is say that frame equals frame plus 1. And I could do it that way, or I could just use the increment operator. I'm going to model that by sprites.length. So this will basically wrap back around to 0 if we go beyond the ends of the array. So we're going to increment to the next frame. If we go past the end of the array, we'll reset it back to 0. So advance to next frame, and then we will say that renderer dot sprite equals sprites at our current frame. In fact, why not just do that in here? We'll set our next frame time to be time.time plus frame delay. Let's jump back out into the Unity editor. We should see our parameters appear here. And there you see, we now have an array of sprites, which is empty. We have our frame delay, and we have a field for our renderer. So I'm just going to grab our renderer from right there. And now we got to assign our sprites. So let's go back into our art folder and look at our Defender sprites. I'll make this a little bit bigger. Scroll down until we see the lander. And I want this sprite. Why is it doing that? Okay. I don't believe I'm making any changes to our sprite. It's very interesting that it's yelling at me. But I want this one and this one. You just say revert. I don't know what it thinks I changed, but if we open that up, I want this one and this one. We're going to animate between these two frames right here. Actually, I want them to turn left and right. So I think I'm going to animate between this one and this one. So let's go back up to here. And I'm going to drag this one into our array. And then I'm going to drag this one into our array. And hit play. You can see if we look at them here in the inspector, you can really see them animating. That's a little slow. So looking at them here, I'm going to move them over to the right a little bit. So that he'll show up a little bit better when we're debugging. And then I want to speed him up. Make this maybe about 1/10 of a second. Yeah, I think that looks a lot better. And let's create a prefab for that. So we'll go down to prefabs, mobs, and we'll just drag him down here as lander. Let's see if we can't create a projectile that our player ship can shoot. So I'm going to create an empty game object. And I will call this player projectile. And I'm actually going to create a new layer for this. And I'm going to call it, I'll put it down here. We'll say player projectiles. We're going to create a layer here for player. And we're going to create a layer here for enemy mobs. And then player mobs. That'll be the base. Actually, we'll just call this humans because there's only one human on one player mob, and it's a human. Now, select the player projectile and assign him to the player projectiles layer. And I'm going to take the lander here, and I'm going to assign him to the enemy mobs and apply all. Okay. So we're going to want some kind of a shape to put under here for our projectile. So once again, I've gone over to itch.io and I browsed assets and I looked for free assets that are tagged with 2D, retro, sci-fi, and sprites. And there's 6 results here. And I think I like this pack here because it says there's 6 bullets in it. And so I'm guessing that these are the bullets here, or some of the bullets. At any rate, I'm going to pull this down and take a look at those and see if any of those are the ones that we could use in our game. So we'll do the free download here. Wait for it to download, and then we'll open up that zip file. So I'm going to extract these to a folder, and then we can take a look at them. So I extracted all them to a folder under Unity Assets. I kind of like this as an image for our bullet. So we're going to pull that into our object as a sprite, and we're going to add a trail renderer to that because in the original Defender, the bullets looked long and thin. So I think I'm just going to add a trail renderer to kind of achieve that effect. So I'm going to drag that out of the way, go back into the Unity editor, and into our art folder. Let me just collapse that again. And I'm going to drag that whole folder into here. I don't think those files are all that big, so it's fine if we drag them all in. And so in here under bullets, I really kind of like that one right there. Okay, so let's create on our player projectile. We just want to drag that sprite onto it. And there we've got a sprite renderer. Now we do want to rotate that -90 degrees so that it's facing horizontal like that. And we're going to want to add a box collider to it. Actually, now that I think about it, I think I want to add a capsule collider. It's got to be a 2D collider. And let's edit that and let's extend it a little bit back. I want to make this a forgiving projectile, so we'll make it a little bit wider than the image and we'll make it extend along backwards a little bit too. And then just in terms of scale of this image, let's make it a little bit thinner because I like the way the projectiles looked in the original Defender. Okay, I think we also want to add our trail renderer, but I think we want to add that up a level. So we'll come up here and we will add a trail renderer. Oops, don't want to add a script trail renderer. And we want it to be very, very thin. So I'm going to drag this way down. I'm not even sure what value I want, but something thin. Maybe something like 0.05. Something like that, maybe. And for time, we want this to be a very short-lived renderer. And for our color, I'm going to actually do a pick from here. And then I'm going to darken it down a little bit. So let me select that. Come over here. And then maybe just make it even darker than that. So to start off this same color blue and then trail off to a darker blue. And we need to give it a material. And I think for the material, I'm going to try this default line material. So if I grab him and drag him, you can see he leaves a little trail behind him. And I think that'll look pretty good when we actually shoot him. So let me just reset this. And we're going to want to create a prefab from that. So under prefabs, let's create a new folder. And I'm going to call it weapons. And I'm going to drag that guy into there. Now we're going to need a script for him, obviously. So in our scripts folder, we will also create a new subfolder called weapons. And let's open that up and create a new C# script and call it player projectile. And drag that script onto there and double click to open it up in the editor. And let's zoom into our code here. And we'll start by adding our serialized fields. We're going to want a rigid body 2D. And again, I could grab this in awake, but I'm just showing you how you can also assign these things in the inspector. We're going to want a value for how fast this guy is going to travel. And we can adjust that in the inspector. And then we want to have how long we want this guy to live. And I'm going to default that to about 1/4 of a second. So let's create a private variable here, a float. We'll call it destroyed time. And then we want to have a Boolean property we can check to say, are we out of fuel? And this will be true if time.time is greater than or equal to destroy time. So in onEnable, oops, I want it on enable. We want to set our destroy time to be time.time plus our duration. And we want to set our rigid body's velocity to be our transform.right times our speed. And so whatever direction we're facing, we're going to fly off in that direction at whatever speed we assigned here. All right, so update. Basically, we want to say if out of fuel, then we want to destroy this game object. I think in future videos, I'm going to introduce object pooling, but for now, we're just going to instantiate and destroy these objects. Object pooling is a way we can save and reuse references instead of destroying them and recreating them. And the reason you would use that is because when you create and destroy objects like this, you're creating garbage on the heap, and then the heap, the garbage collector has to go clean that up later, which can cause lag spikes in your game. But that's a little bit more of an advanced topic, and we'll save that for a later video. Now, we want this to be a trigger. So we're going to handle on trigger enter, and it's important to use on trigger enter 2D since it's got a 2D collider. And what we're going to do, we're going to rename this guy other. So we're colliding with something else, or we're entering the trigger radius of something else. So we're going to say if other.tryGetComponent, and you remember we had that destructible script that we put on our lander. So if we're hitting something that's destructible, we want to grab that guy, and then we just want to say destroy me on it. And normally with a projectile, I would also destroy the projectile right here. But I think that in the original Defender, the projectile would keep going and could hit a target that was behind this one. So I'm not going to destroy the target until it runs. I mean, I'm not going to destroy the projectile until it runs out of fuel. I'm just going to let it keep going. So that should handle hitting the enemy and destroying it. Now we need a way to actually fire this projectile. So jumping back into Unity, let's go find our player ship prefab. Assuming that Unity compiled everything okay. So I'm going to open up our player ship prefab, and we're going to add a new empty game object here. And I'm going to call this gun. And we want to position the gun right at the front of our ship. And this is where our projectile is going to come flying out. And I'm going to create a prefab for the gun as well. And under scripts, weapons, let's create a new C# script and call it gun. And after Unity recompiles, we'll drag that script onto our gun component. And override that to apply it to the prefab. And then we'll open up this gun script and start editing that. So once again, we'll start by editing our serialized fields. We want a prefab for our projectile. And we're going to want an audio clip to play when we shoot. And then we want a cooldown timer to keep us from spamming the fire button faster than we should be able to. I'm just going to call that fire delay, and I'm going to default that to about 1/4 of a second. And then we'll add a variable here for our cooldown, call it cooldown time, and we'll add a property called kinFire, and it's just going to be true if time.time is greater than or equal to our cooldown time. So this behaves pretty much just the way our out of fuel works. We're just setting a timer, and then we're just checking to see if the current time is greater than or equal to that time. So in onEnable, we will set our cooldown time to be time.time. So we want to be able to fire immediately when we first start up. And then we will have a public void fire gun function. And we'll say if not kinFire, then just return. Otherwise, we're going to play our fire sound on our sound manager. Play audio clip fire sound. Fire sound. And then we're going to instantiate a projectile. We'll just say instantiate using our projectile prefab at our position using our rotation. And it's complaining that we're inefficiently accessing this built-in component. So here's what we're going to do. We are going to cache our transform. And then on awake, I will say transform equals transform. And then down here, we'll use our cached transform values. Now that we've got a projectile, we want to set it to be active. So I actually want to, on that prefab, set it to be inactive initially. So this will cause the onEnable to fire on the projectile, which will actually add its velocity for us. And then we want to reset our cooldown time We'll say it's time.time plus our fire delay. And that should be all we need to shoot a gun. Go ahead and get rid of that. And let's find our player ship. We don't currently have it here, so I'm going to look for it. Player ship. And we're going to add a serialized field for our gun. And where we handle the on fire, currently we were just logging a debug message. We are going to say gun, fire gun. And that should handle that. Let's jump back into Unity. So on our gun, we should see some serialized fields appear here. So let's grab our player projectile prefab and drag that right up there. And actually I want to override that and apply that. And I want to work directly on the gun prefab itself here. And then let's go find the fire sound we want to use. Under our sounds, laser weapons, free. And let's try a few of these light blasts. Kind of like that one, Laser Blast 5. Yeah, I think I like Laser Blast 5. So we'll go back up to our gun, and I will drag Light Blast 5 into the fire sound. So that looks good for the gun. Let's go up to our player ship prefab again. Collapse a few of these things, and now we need to drag in our gun prefab. So under weapons, actually I can just drag it from right here, gun. All right, all that looks pretty good. Let's take a look at some other things. I want to look at the colliders, the way things we've got set up on the lander. So let's see, he's got a box collider on his sprite. We need to set that to his trigger. Take a look at that collider. I like that. Maybe we'll duplicate him a few times. So drag him over. Duplicate them, and so duplicate them, move them up, and duplicate them again, and move them down. That'll give me some things to shoot at. Let's go take a look at our player projectile again. So we've got this trail renderer. We got our capsule collider. He needs to have, oh, it needs to be his trigger. And we need to add a rigid body to this guy. Since the targets don't have rigid bodies, at least one of them has to have a rigid body. So we'll come in here and say add component, rigid body 2D. And we're going to freeze his rotation. He shouldn't rotate. We're going to set him to be kinematic. And he'll be pretty fast, so I'm going to set his collision detection to be continuous. And I think that should do it for the rigid body. Let's just give this a quick test and see what happens. Can make this window a little bit bigger. Okay, for some reason there's a projectile sitting on the screen. And it's not moving. I don't see any errors in here. I'm thinking we never added our player projectile script. So let's go down to our scripts, weapons and drag the player projectile onto there. We need to drag his rigid body down. That looks good. Let's see if that fixes it. I'm not super happy with that. And it's definitely not blowing anything up. We're going to have to tweak that a little bit. First, I think I'm going to tweak the player projectiles trail renderer a little bit. Pull that down a little bit more. That's fine. I think for the color here, I actually want to fade the alpha out as well. And let's look at some other things. We don't want it to cast shadows. That shouldn't matter. And for the duration, I'm going to make it not last quite as long. Let me see what that looks like. So that looks better. Now we just have to get it actually hitting the target and blowing it up. Let's start by looking at some of our properties here. We have the player projectiles. That's good. Let's look at our enemy. He is on the enemy mobs layer. He's got the destructible script. He's got this box collider. I'm going to move the collider up. That's the problem, I think. The box collider needs to be on the same component. There's no rigid body on this guy, so I think the collider has to be on the same component as this destructible. Because when we're colliding, we're getting this, and we're looking for the destructible component on it, and we're not finding it. So I'm going to copy this component. I'm going to remove that component. I'm going to add a box collider 2D and paste component values. So that should look the way we had it before. Let me just check our physics settings. I'm going to go into player, build settings, player settings, physics 2D. We need to change all this. So humans, that looks good. Player projectiles should only collide with enemy mobs. Enemy mobs can collide with the player. Okay, I think that's all good. Go ahead and save everything and hit play and give that another test. Okay, so that's working. I think I might turn down the volume on that fire sound a little bit. The other thing is that the up and down motion seemed a little... It was hard to get on target. Like maybe I need to add some more granularity maybe to the up and down. So let me go into my player ship and maybe reduce my vertical speed a little bit. I'm going to try it with the Xbox controller this time instead of the keyboard. Yeah, I like that better. So to change the volume of that play sound, I'm going to go into our gun script. I'm going to add a serialized field after the fire sound. And I'm going to call that fire sound volume. And I'm going to set it at like 0.3. And then where we play the fire sound, we can pass in fire sound volume to our play audio clip method, which, as you may recall, has a volume parameter, which defaults to 1. And we'll go and give that another quick test. Yeah, I like that better. All right, it's starting to look like a game. Well, I think that about wraps it up for this video. If you found that useful, and I hope you did, do me a favor and click the like and subscribe button. It really does help me to grow my channel. And as always, if you have any questions about anything I covered in this video or suggestions about things you'd like to see, drop a comment below and I'll get back to you as soon as I can. And if you get stuck or have any difficult problems you can't solve, check out my Discord server. If you post a more detailed question there, I can give you a much more detailed response than we can have on a YouTube comment. So, I look forward to the next video where I'll start getting into some game state logic, some state machines, and we'll start having our enemy ships do more than just sit there and let us shoot at them. So, thanks so much for watching, and good luck on your game development journey.